This is the solution to video assignment 7A. A disk with mass 1 as 2 kilograms is spinning in a circle of radius 1.2 meters on a frictionless table. The rope attached to it is connected through a hole in the table to a block of mass 2, just 3 kilograms. What is the angular velocity required for the disk to rotate in order for the block to not move? So let's start with the mass of the disk, which is 2 kilograms. Radius of the circle is 1.2 meters. And the mass of the block, 3 kilograms. So looking at what we've learned so far in physics, let's make a motion diagram or a force diagram. So we know we'll have this be M2, the block that is hanging, and we know that there's a tension force pulling up on the block and gravity pulling down on it, which is just M2G. And we want the acceleration to be 0 for it to stay at that point. So we know that the tension will have to equal the gravity force. Those forces will cancel each other and equal 0 for the acceleration. Drawing another diagram for mass 1, the disk, we'll see that there's a tension force pulling on it to the center of the circle, and we also need a force pushing out, which is going to be mv velocity squared over the radius. And so these two forces have to equal each other. So we'll write that out. T is equal to mv squared over the radius. And we also know that v is equal to the angular velocity times the radius. So now we have two equations. And both of these equations have t in them. That means we can set them equal to each other, which is what we want to do. Also substituting this for v. So let's do that. Mass 2 times gravity is equal to m angular velocity times radius squared over r. Now we can do some more simplification. What we're trying to find is the angular velocity required. So let's do some more simplification. M2, that's m mass 1 by the way, is equal to angular velocity squared, radius squared over the radius. We can do some canceling and see that it will just be the radius on top, since this cancels with that. And then now we can try isolating for angular velocity. We'll divide the r on this side and the mass 1. So we have mass 2 times gravity over mass 1 times the radius is equal to angular velocity squared. Finally, we can just square root. So angular velocity is equal to the square root of m2 times gravity, mass 1 times the radius. And now all we have to do is simply plug in angular velocity is equal to the square root of 3 kilograms times 9.8 meters per second squared over 2 kilograms times 1.2 meters. Solving for all that, we will get an angular velocity of 3.5 radians per second. So solving this problem required knowledge of forces, force diagrams, as well as knowledge of angular acceleration and velocity equations. And the process of solving this just involved a lot of rearranging equations and using algebra to find what velocity was required for the block to stay elevated at the same height. Thank you.